Good evening, Professor. This is my personal timetable of this week. As I already mentioned, that this week I have started the two different type of cases. Normally, three different type of cases, but first two cases I go with this week. Uh, so this is my weekly plan. So first focus already known that the biosensor research to start with the new BATIO3 chip, and also simultaneously in the last weekend on Saturday, I talked with Dr. Daniel. So we decided to start from the initial, like we have to just compile all the things, all the figures, all the contents in one Dropbox folder, and we have to write again, or like to just check, go through our content. Either the content is not, it will not be repeated or will not be plagiarized by any software first. We are the main focus is to make a conceptual content in the review article. So these two things I go with in this week. So so this is my BATIO3 biosensor research plan. So first, this is the biosensor research plan for if we use BATIO3 chip. So onto BATIO3 chip, we have to just directly immobilize antigen nanoparticle, and then rinsing with PBS, and then afterwards we have to use MUA, then EDCNHS, and then wash with the ethanol, and afterwards we have to put the antibody, and using the blocking with BSA, and washing with the PBS, and again we have to fix with the antigen with our existing antibody for binding, and afterwards we have to wash with PBS. And these are the process if we use BATI3. But as per we have only 5 BATI3 chip, so it's a crisis of BATI3 chip before to apply this whole process onto BATI3. So we have to just confirm this process is working on or not. So from the last week or still this week, we have to use the normal P6 chip, and we have to follow this whole process onto that chip. So if we and we got good results as well by using these methods. So in the next slide I will explain. So before to explain my results, I just want to show my schematic overview of whole process. Like first, it's a BATIO3 structure onto the surface. It's a hollow, it's a pore structure. So if we immobilize antigen nanoparticles, so the antigen is stuck in between the pores, and then washing with the PBS, unwanted antigen silver nanoparticle wash out from the surface, and then afterwards existing and a silver nanoparticle combined with the MUA after immobilization of MUA, and then afterwards MUA we have to wash with the ethanol, or we can use the PBS, and then afterwards we have to put EDCNHS, and then ethanol washing, and then antibody immobilization onto the surface. And the whole process is almost same that I already discussed in the last personal timetable. So this is the process that we have to follow by using the BATI3 chip. But before to use BATI3, we have to just focus onto the P6 chip, normal P6 chip. So in the last week, I have made the 4 different type of cases. So in these cases, I found that if we use the nanoparticle, so our result is more precise and more specific, or you can say sensitivity is more increased if we use the nanoparticle. uh, and so uh, these are the process that I have followed. So these are the results also. Until now, this antibody, new I previously I just used new antibody and amyloid beta antibody. There are two four different, on first four chip I use new antibody, and last four I used amyloid beta. So the result is quite impressive and the value is stable. So I found that because of the nanoparticle, the result is more precise and more binding affinity is more stronger than the graphene if we use onto our P6 chip, or either in future if we use BATIO3. So the result is more precise and better than the previous results. So this is the case too. In this case I just use the gold nanoparticle in place of the silver nanoparticle to check whether which one is more better for our research. It's like, you can say, the I just check, like, it's a selectivity process. So I found that the gold nanoparticle is also getting more results. These are the previous results that I found. So only one chip is not getting the stable results, but as per the first three chip, I found that the value is stable and more than the other chip, other process. So the gold nanoparticle is also getting better results, and in this case I just use the gold nanoparticle directly with the MUA and then EDC NHS. Previously, if we see that there is no use of MUA here. So if I use MUA, so I found that the values is stable and the mu is equally binded with the gold nanoparticle as well as also connected with the EDCNHS. So due to the presence of gold nanoparticle, the value is more stable than the silver nanoparticle. So this is the results. It's the 3.5 and 3.43 nanofarad up till the antibody mobilization, and this one is the case for. In this case I use both nanoparticle together, AG nanoparticle and gold nanoparticle together. So the result is not stable, so I have to just exclude this case for, because there is no as such good results of this case. So this is the result. So as you see here, there's no stable results, so I just exclude this case. And last week I finalized the case, three final case of the from the cases of the four cases. So I found that in the case 1 I just use silver nanoparticle and MUA, EDC, NHS, antibody, BSA and antigen. And in the second case I use the gold nanoparticle, MUA, EDC, antibody, BSA and antigen. But in the third case I just have to double check again by using the two nanoparticle together in one case. So this case is still I'm working, and of these two cases I got the results. So here I present my results of the first case. So the first case is like, we use antigen nanoparticle and then again MUA and then EDCNHS antibody. So until now, step 7, I found these results. So I used amyloid beta antibody, it's a 142 antibody. So I found that the result is quite, you can say, not fully stable, but I was amazed when I saw that the results goes into the 445 nanofarad, 103 nanofarad, 109 nanofarad, 339 nanofarad. So again I have to repeat this case and to confirm about this case, like the value is again, if I am getting the same value again, so I have to finalize either this case or other case. But in this case I got this results until now by today, and tomorrow I have to do this again for confirmation this result is getting if I getting the same results or like nearby the same value, so then I have to go with this case onto the BATIO3. And this case is the other one, like I use the gold nanoparticle, any MUA, EDC, and antibody. Until antibody this results is a 32.6 nanofarad, 36.9. In this case I found that the first 4 chip is getting the result is stable, but unfortunately at chip 5 and chip 6 I got the higher results than the last 4 chip. Uh, I was thinking about like how we can get the stable results still. So tomorrow morning I have to repeat this case to both again, and to if in this week anyhow I have to complete this whole cases and to confirm which cases is suitable for our BATIO3 chip, because it's basically only it's the final 3 cases. Otherwise we have to use go with the case 1, because case 1 is more favorable than the other cases, these 2 cases. So case 1 is more good, so I have to repeat this again tomorrow to getting confirmation of the existing values that I got today. So tomorrow I have to repeat this again, and if I'm getting the same value or nearby same value, so then I have to use BATI3 chip for using this case first onto the BATI3 chip. So sir, until now I just today I just use the case 1 and case 2, not case 3, because I'm not sure about the case 3. That's why I just go with the first case 1 and case 2. So tomorrow I have to do repeat this cases and to confirm, to getting the confirmation about the results like what I got today. If I'm getting the same, then I'll go with the real BATI3 chip. Thank you, sir.